I'm going to make several mistakes just to start my talk. So the first mistake is I'm going to be very specific in what I talk about. The second mistake is I'm going to ask for audience participation, which can always go wrong. And the third mistake is that I sometimes talk a bit quickly, so I'm going to try and slow down. So let's start. Who here thinks that the AI age we're living in and entering into is a new kind of industrial revolution? You know, if you think this is the case, maybe put your hand up. We have 1, 2, 3. We've got a few hands. Okay, so I'd say about a third, maybe 25, a third of the audience. Who here thinks it isn't an industrial revolution? It's just business as usual. Less hands. And who here doesn't really know? Who here is unsure about this? Okay. There we go. So let's say that we've got a small number of people who are convinced, yes, it is. Probably a large number of people who don't really know, and a small number of people who think it isn't. Well, that sounds like something we should get more information about as policymakers. So my goal here, and the goal of my organization, is we want to make sure that increasingly powerful AI systems actually benefit all of humanity. And when we define sort of AGI, we use a specific definition, which is really machines that outperform humans at most economically valuable work. And so I think this is something that we as a policy community can think about. What does it mean when the majority of work gets done by machines and value accrues to machines? And how does society look better in that world? So my very specific solution for you is measurement. I think that the era we're living in is where we can see AI on the horizon, and it's making its way towards us. We have examples of it around us. And what we don't really do is we don't measure enough aspects of it to be able to predict what it's going to do to society, when bits of it are going to arrive, and how we can take advantage of it. So for the rest of this talk, I'm going to give you some measures that me and my colleagues have been working on for a number of years. I'm going to talk about ways that I think policymakers can sort of do useful things with regard to measurement. I'm going to give you examples of why measurement sometimes is a really bad idea that doesn't do anything that I just said it would. And I'm going to conclude with a hopeful message. As I'm English and, you know, usually quite dismal, this is rare for me, so bear with me. So, you know, where have we been? Greg showed you this earlier, that on the right-hand side you see image recognition. On the left-hand side you see image recognition, and on the right-hand side you see speech. I'm showing you these graphs because I want to communicate to you that the AI we have now is very general purpose. Similar techniques that allowed us to do great things in image recognition unlocked speech recognition as well. And if you look at these graphs, you'll see that the trend lines are related to each other. We see a rate of growth that is consistent in different domains. And this general utility fact of it is important for what we think about as policymakers. Now I'm going to talk to you about how I think we can actually make good predictions about what's to come. So this graph is an analysis of key results in AI that have occurred over the last 6 years. And what we did with this analysis is we looked at the resources that went into creating these results. So whenever I have an AI system, I need to train the AI system on a task, and that requires data. And then the AI system will learn to perform well at that task. And what this graph shows you is the amount of computation that we've given these AI systems. And what we noticed is that the increase in the last 6 years is 300,000 times. So 300,000 is kind of a crazy number. Moore's law gives you 12 times. 300,000 is equivalent to your phone battery lasting 1 day in 2012. And now in 2018, this phone battery, if it increased by 300,000 times, would last 800 years, which would be nice, but that's not the world we live in. I think this is more significant than we can imagine. So if we look at the image recognition result, you'll see that that uses a relatively small amount of computation, but does substantial things to the economy. A few years later, we see one of the first results in translation. This is work done by Google. And translation is a hard task. You know, many of you are translating as I'm talking. You're taking the concepts I'm saying and you're putting them into your home language or different way of reasoning. And this is, I think, one of the amazing things about being human is we're able to do this. And yet, if we look at the performance increase that we see in the last few years, we just this year or in 2016 got to approach human level on this translation task. But there's a key ingredient here, which is the amount of compute we used to do that was on the order of 100 petaflops. That's in 2016. Now, before going on stage, I checked the most powerful supercomputer in the world today, which is one at Oak Ridge Lab in the US. That's running at 120 petaflops. So in 2016, we were training AI systems using more computation than the fastest supercomputer in the world at that time. And I think this is another significant thing. AI is increasing faster than our intuitions about it would suggest. And it's increasing faster than the traditional tools and measures we use to assess what is technically possible. Another way to get a sense of this is we went from being able to solve arcade games from the 1980s, like Space Invaders in 2013 or so, to systems like Go in 2017 and 18, and other computer games such as Dota, which OpenAI has worked on. But if you look at both of these points on the graph, you'll see just how dramatic the increase in performance has been. And the AlphaGo system alone used something on the order of 400 petaflops. So that used more than any supercomputer can get you in the world today, because it uses lots and lots of computers in parallel. And what that means is that we're capable of building AI systems today that are far beyond the capabilities that we can traditionally reason about. Just to give you an example of what this looks like, and this refers to what Greg showed you earlier, here's a robotic hand we trained to start manipulating something. Now, this is something that we did this year, used a lot of computers, is very difficult to do by hand, and it's made possible by this increase. And just to hit you at this point one final time, the graph I showed you before is a log graph. If I graph it linearly, you see this. And what you see is that the last year, we've had maybe 2 or 3 points that have gone above to a point where you can see it. And the neural machine translation example is the best from 2016. So things are getting faster than sort of our intuitions would suggest, and the scale of these things is growing. Another useful way that we can think about measurement is how much do things cost. So this is some data from a Stanford project that means we can now start to assess these systems with what is the dollar cost of training a capability. And this, to me, is a symptom of this industrialization we're living in. Like, once we can start to account for things, we can plan services around it. So though this may be like the nerds having fun and, doing a very specific calculation, this same reasoning can let you calculate things like, what is the cost of training a transformative healthcare capability? How much does it cost me to train a drone to go and do some useful surveillance for public safety for me? All of these ways of measures can let us make better decisions. Another useful thing that we can think about is where AI is being developed. So some preliminary data from the next version of the AI index from one conference shows us that the key actors in AI may be furthering their lead. You have China and the US submitting record levels of papers to a recent conference called AAAI. And these kinds of metrics can help us make decisions about where to make scientific bets in specific countries and where to play to our advantages. So I've told you all of this to try and convince you that measurement's actually useful. It can tell us real things that we can use to predict things about the future. And so where do you come in? Well, I think there are areas today where policy needs to actually get into the measurement game. Here's one example, which is self-driving cars, where we have lots and lots of companies around the world developing this technology. We know that this technology will influence the economy in very, very significant ways. The best single source of data that I can access on self-driving car performance today is accident reports filed with the California Department of Motor Vehicles. There is no single graph that gives me a sense of the performance increase of this technology, and there's no one really doing a holistic monitoring exercise to let me know when are the cars going to make some percentage of people need to change their jobs in my economy. So I think if you're a policymaker, you might want to look at examples like this and think, are there ways that we can measure this? You know, in Estonia, we recently authorized self-driving cars on the road here, right? And so now we can start to think about, can we gather some performance data on those cars in our country? We don't need to access the IP of the companies that developed it. We don't need to violate any of the commercial elements, but we can get metrics, and these metrics can let us plan things. Another example, and this is related to my work on the malicious uses of AI, is that there are areas where we definitely want to monitor things for kind of safety and security. So what you see here is a video of a drone learning to land itself autonomously in a simulator. And a student developed this and they emailed it to me last year, and I said to them, that's very interesting, but I don't care, because it's not happening in the real world, and so I don't believe this is significant. And so a few months later, they emailed me and they said, well, thanks to something that OpenAI developed, I've been able to make it go into the real world. And they sent me a video showing that the drone now does this stuff in the real world. So this makes me nervous. Like, we at OpenAI had no idea this was happening. Drones like this are kind of fine, but future versions of them are going to have very significant security challenges. And at the same time as this, all of this is sort of happening in the open. So I'll give you another example. These are 2 research papers I was reading over the weekend, because that's what I do with my spare time. You know, one research paper is about a data set to let you learn aggressive flight behavior with drones, and that's if you're drone racing, which is becoming a sport, you want to learn how to do that effectively. Another paper is about using drones to monitor wildfires and be able to provide autonomous surveillance of natural disasters. You know, both of these are things that policymakers want to encourage, but what we really, really don't want to encourage is what happens when we combine all of these technologies and weaponize it and create things that threaten security and stability. And I'm saying this gloomy and depressing thing because it's important to remember that this happens with every bit of technology that we've ever produced. Bad people have figured out bad ways to distort it. And so a challenge for the AI community and for the policy community is going to be working out, are there bits of research which we need to be slightly more private about? You know, OpenAI suspects that in the future we may not publish on certain areas because of safety or security concerns. We definitely want to make the area that we're controlled about the smallest possible area, because otherwise you're going to destroy like lots of economic benefits and lots of things that can help people. So a challenge for you is, how do we think about this and how do we do it? Now, why is everything I just said potentially not useful? Let me show you 2 examples of what happens where when you measure stuff, you may be doing the wrong thing. So at OpenAI, we had a competition to try and train various AI agents to play games, and so we measured their performance on this. We had one AI agent that was doing very, very, very well, and so we went and looked at what it was doing, and its goal was to race a boat around an obstacle course. So you have the boat, it's going backwards, so that should be a problem. It's not completing the course at all, and that's because the boat, or the AI, has figured out that it can instead just find some high-scoring crates in the center of the map and set itself on fire repeatedly while hitting them. You know, this seems bad. I don't want this boat to be a boat that I'm on in the real world, and it's an example of how measures can actually, if you don't design the measure correctly, bad things can happen. Another example is, this is a robot we're training to try and, you know, move its hand to a location on a table. And it does this pretty well, but it does something surprising. Some of you may have caught that, and I'll show it to you in a second. The robot actually learns that it can just move the table rather than move its hand, which is, again, something you never want to happen in the real world in a carefully controlled setting. And I think it highlights how we need to think about measurement and also not be too naive about the problems of it. So my conclusion to you is that I think that policymakers are confronted by like really weird stuff with AI, because it's a general purpose technology. You have the ability to create new markets and unlock totally new types of scientific research that will benefit all of society. And at the same time, you have the potential for misuse of this technology and accidents. And I think that the solution actually looks a lot like what we've been doing with weather forecasting and climate analysis worldwide for years, which is you just set up measurement organizations in lots of different countries, and they all measure different things. And what they do is they talk to each other when they try and find things that they can't necessarily measure well. So a hypothetical example could be a measurement organization in South America spots a case of misuse of an AI technology. It's not sure how to analytically think about this, and so it talks to some collaborators it has in America and North Africa, and these organizations help it and provide information to it, and maybe one of them goes and educates other measurement organizations that are going to care about a similar thing. I think that this is actually very achievable and does not cost much money at all, and you can implement it in a bunch of countries kind of quickly, because one of the mandates that government has is to measure things and tell me as a citizen what's going on, when is my world going to change, and what are you going to do about it? So I think that equipping us with better information to think about this is kind of important. So my conclusion is I think measurement is an amazingly powerful tool, and if we think about being intentional about it, it can lay the groundwork for a kind of global collaborative policy community that can answer that question of, is AI an industrial revolution? You know, I hope that if we're successful at this, lots of people can put up their hand and say, yes, and I can tell you why. I have this like chart or this measure that I figured out. We see this as a core part of our mission. You know, we think that for AI to benefit the world, we need to intentionally go and create these communities. And so I'm here today to say, like, let's get started. And if you have any questions, you can send me an email. So thank you very much.